project. This is our project. This is a Rubik's Cube solving robot which has been implemented using FPGA. The frame of this robot has been built using Lego technique, and apart from that we also got some parts 3D printed, like these green gears which have been attached to the stepper motors in order to rotate the Rubik's Cube, and also these spring pieces which are used to provide structural integrity to the robot. This robot uses a Z-board Zybo 7000 in order to solve the Rubik's Cube. So first of all, there are two sensors. One of these sensors used to scan the corner face, and one of them is used to scan the edge face. Now how it scans the entire cube is that it rotates the cube in order to detect a particular face, and then it backtracks those moves so that the cube stays in its original position. After it has scanned the entire cube state, it uploads that to the FPGA, and it runs a simple CFOP solving algorithm in order to solve the cube. The moves of the cube are then generated by this algorithm, and then they are uploaded to the stepper motors. These are NEMA 17 stepper motors. They have very good torque and speed, and they allow the cube to move very smoothly and without any jitters and without getting stuck. In order to drive these motors, we have used six A4988 motor drivers. These motor drivers there are 4 pins in order to control the stepper motors. They are 1A, 1B, 2 and 2B. So the motors are bipolar motors, that is why there are 4 pins in order to control these motors, and they move in steps. So the program basically generates a pulse, and the motor basically moves in steps according to these pulses. Apart from that, in the motor driver, we have a step and direction pin. All of these step and direction pins go to the GPIO pins of the FPGA board. And apart from that, we also have a VCC and ground. Again, this goes to the VCC and ground pins of the FPGA board. There is a V motor and ground pin which is connected to an external 9-volt battery, and there are 6 enable pins, and each of these enable pins are connected to separate PMOD pins of the FPGA board. Apart from that, in the color sensors, there is an SCL and HTA pin for each of the 2 sensors which have been used, and there is a 3.3 volt and ground pin also for each of the sensors which are connected together to the 3.3 volt and ground pin on the FPGA board, on the PMOD pin of the FPGA board. So this is the Verilog code which we have used for running the robot. This is the main module. This is a top level module which controls the entire implementation. As you can see, there are multiple inputs and outputs which have been initialized in the beginning. There is an input for the clock signal which is 100 MHz. There are 8 switches which are used to control the state machine. A finite state machine has been used in this code. There are 5 buttons which are used for moving the cube using user input. There are JA, JB and JC pins for initializing the PMOD ports, and there are also 8 LEDs which are used for user debugging purposes. You can see that a clock generator has been also initialized. Apart from that, there are separate codes for running the steppers, and also one for I2C. There is a separate module for edge reader, the edge color sensor and the corner color sensor. There is one for translating the colors which are scanned from the color sensors according to the RGB values. A solving algorithm has also been implemented. This is a very complex solving algorithm which is over 1400 lines long. Then there is one for update state. So as the robot keeps scanning each face of the cube, it keeps adding these states to the cube state to the update state module, and it adds to the cube state. There's a determine state module. Then there's a spin all module which backtracks whichever move has been carried out by the cube to scan a particular face. And then there's a sequencer which is used for tracking the sequence of the finite state machine. Also a serial module which we haven't been used. This is used for user debugging, and an external Python script has been used for this part. Now I will show the simulation. This is what the simulation looks like. As you can see, there is no there are only Z and X values. So this is our entire setup. As you can see, we have facilitated all the connections using a breadboard, and the FPGA board is over here. And here you can see the implementation. we have tried to run the motors in a clockwise and anti-clockwise direction for a particular period of time just for testing the motors. So this is our implementation. We were unable to make the robots solve the cube and like scan all the faces of the cube, but we were able to get the motors to work, and we will continue to work on this project so that it is able to solve the cube as well.